Dr. Inductor, and now I'm going to talk a little bit more applications and functional uses of resistors, okay? Now we normally encounter your everyday resistor as something like this. It's like looks like a peanut. It has two leads coming out right here, and it has 4 to 5 stripes. Okay, I will make a video of what these stripes actually mean, but they just indicate the value of the resistor and the tolerance and sometimes the temperature coefficient. Okay, this is what one actually looks like. Don't know if you can see those stripes. This is horrible autofocus, bad quality to begin with, but this is your normal resistor that you'll usually encounter, okay? As we learned in the last video, its schematic diagram is just this zigzag shape, okay? We also have things called variable resistors, or potentiometers, or rheostats, okay? This is a side view. It has 3 leads, okay, top view, and a dial. You spin this and the resistance goes up or down. This is its schematic diagram. This is the part that you turn, the dial, and then just the resistor, okay? And what it, here, let me show you. This is what one actually looks like, okay? Usually they'll have actual knobs that you put on here, so it's easier to spin, okay? You want to know how one works? I bet you do, okay? So you have your negative lead and your 2 positive leads. The reason they have 2 positive leads is just so when you turn it this way, it gets larger or smaller, depends on the manufacturer, okay? So you'll have your 2 negative leads right here, and a wiper. And this is a resistive material. Sometimes it's carbon, sometimes it's not. Depends on the manufacturer and the model and whatever. And what did we learn about factors of resistance? We learned that length is one of them, right? So as this brush travels across this conductor or this resistor, it will increase or decrease your resistance based on what lead you're using. And sometimes they'll even let you go all the way off the conductor, so there's infinite resistance, we call it, okay? So yeah, it's all great, right? But what's the use of impeding electricity, okay? Here's one use. I'll show you. So let's say you have a just regular circuit with, this is called an LED, light emitting diode. I'll get into those in the future, but they're lights, and they only let current flow in one direction, and they cannot receive too high of a current or too high of a voltage, okay? So you have to limit the current that goes into it, alright? And you do this with a resistor, okay? You, using Ohm's law, you find the resistor that fits the limits of your LED, but yeah, it'll prevent your LED from getting fried, so it's very useful, okay? Resistors. We also use them in like applications of integrated circuits, but those are really complicated, and I won't be getting into that for a while. So yeah, we also use potentiometers too, just for fine-tuning your voltage for what circuit you want, and using microcontroller or something. So yeah, there's the basic resistors and stuff. I'll see you next video.